Welcome back to my channel Kuluru Vineeth. So we'll continue the arrays playlist, and today's question is finding intersection of two sorted arrays. That is, we should find the common elements present in array 1 and array 2, and at the end return the common elements of both the arrays. Okay, this is what the example looks like. Here the example is given array 1 is containing elements 1, 3, 5, 7, 9, and second array consisting of 0, 1, 2, 3, 4, 6, 8, 10, 12, right? So as we can see, the common elements in both the arrays is 1 and 3, so our output should be 1 and 3, right? Question is clear, right? So yeah, so the simple and basic intuition to come to solution for this approach is use the two loops and compare if the element is present in both the arrays or not. If it is there, we store that into one separate list, and at the end return that list. Okay, so let me start writing down an approach so that it will be clear. Approach 1, using two loops and comparing them. Okay, so let me name this as approach 1, and since now we will be having a two input array, so let me name first one as nums1 and it is nums2, and it will be of list of integers, and our output will be also the array. Okay, fine. This is the approach 1 with the two parameters, and return type is also list of integers. So let me take one array to store the result, so let me name that as intersection and initialize it, invoke it. Fine. So now simple, straightforward, we'll traverse using two loops both the arrays and check if the common element is present. We'll add that element to the intersection array. Fine. So this we traverse that, and what I do is, if this contains the above element, I will straight away add to intersection array. Okay, straight away, this is the thing. And at the end what I do is I just return this array. Simple, straightforward, as I already mentioned. So now coming down to the time and space complexity, since we are using two, contains is again a loop iterating through the complete nums2 array, so the outer loop is order of n, that is size. Again inner, if that contains, again it is kind of order of n, so the time complexity would be order of n square, right? And now coming down to space complexity, since we are using extra array to store the result, I would say it is order of n. This is the time and space complexity for this approach, right? Fine. Now is there any other way that we could come up with a solution for this? There's already a hint, because given our input arrays are already sorted, why don't we go ahead and use two pointers approach, right? So let me write down that approach as well. Using two pointers. Okay, let me name that as approach 2. Here again input parameters remain same with the two arrays. Okay, and return type would be list of integers, and also same, I would take extra array to store the result, that is mutable list of int. And now let me take two pointers for array 1 and array 2. Okay, come on, right? So now what I'll do is I will just iterate both the arrays, comparing elements of both arrays parallelly. Okay, I will just do this one. So here the condition would be, let me use the modern when. Here condition would be if nums of I is less than nums2 of j. So in this case what we have to move forward either of array 1 or array 2. So this condition would determine in which array we have to move forward the pointer, right? If this is the case, then obviously what we do is I will just a second. Did I miss something? Just a second. Sorry, arrow mark. Forgot, guys. Sorry. Okay. Yeah, we just increment the I, or else if the vice versa condition, if nums of I is greater than nums2 of j, I will increment j. Else the condition is both the elements are same, then we directly push that into intersection array and we increment both the pointers, right? We add any one of element and then I will increment both the pointers, and finally that intersection will have the common elements in both the arrays. So this was the simple two pointers approach to find the intersection of the two sorted arrays. Right, now coming down to the time and space complexity, since we are traversing the arrays just once, the time would be order of n, and space again it mounts to order of n, since we are using one extra intersection array to store the result. So this was the approach to using two pointers. Okay, fine, we are done. So now is there a other way that I could use? Okay, again straightforward, there is already an inbuilt functions available to find the intersection of two sorted arrays. So let me write down that as well. Approach 3, using intersect function. Okay, so let me name this as approach 3. So again parameters remain same, this one remains same, and also return type would be same. Fine. So what I'll do is, first we have to convert the given list of int to the set, and then both the arrays to set, and then find the intersects of both sets. That is what is the requirement for the inbuilt intersect function. So let me write down that. So what I am converting into set first, and then we'll apply intersect function on the other given input sorted array. This also I will convert, and finally to list. So this is what the intersect inbuilt function usage looks like. Okay, fine. Now coming down to the space complexity, I would say it is again order of n, and also space is order of n, since behind the scenes it's same as the approach we have written above. Okay, so fine, these are the three approaches for this question. Now let's start writing main function and see what the output of each approach you have written looks like. Okay, let me take examples. 1 second. And so I'll take the same examples I have shown you so that it would be easy for us. This was nums1 and nums2 is again so this is nums2, and now initialize the object of the above class I have created. So it is, just give a second, finding intersection of two sorted, right? Done. So let me print again. Let me store first result of list into one variable and then we'll print that list. Okay, so that is, let me call approach1. Here it will be nums of 1, nums of 2, and straight away I will traverse that above 1 and print the element, and do the same for approach 2 and approach 3. Just I will change the naming conventions. So it is approach 2, it is approach 2, this also to approach 2, approach 3, and this also to approach 3, approach 3. Okay, and let me print here new line so that it will not confuse us. Okay, so let's execute this and see what the output looks like. There is something I missed. Okay, forgot. I always keep forgetting the arrow functions in when function. Fine, but I'll learn eventually. Yeah, as you can see, the output of approach 1 is this, and output of approach 2 is this, and output of approach 3 is this. They're all same, so that means it concludes our approaches are same, leading to the common solution, right? So that was it for today. Thank you so much. Keep watching my videos. There will be a lot more exciting content coming up your way. Thank you.